There's people born at the same time as that article, like having their bar mitzvah this year.
HBR, data science, sexiest job, 21st century.
Hi, everybody. Welcome to Saturdata, your favorite weekend data podcast. I'm Shif, and I'm with my friend Sam. How you doing, Sam?
I am amazing. I just woke up from a nap not too long ago, so I'm having a great day.
Nice, and I'm coming off a run, so feeling good, ready to seize the day.
This is why we do these things on Saturdays, because it's nice and relaxed and chill vibes.
Totally. I don't think you want to come home from a long day of data work and then record a podcast about data work. You need a little bit of distance.
I'm likely to say something I don't mean on those days.
Totally. Totally. And because we're here on the weekend doing a podcast about data work, that's actually the topic of today's episode is like, what does that data work actually look like on a day-to-day basis? Because you have all this glamorous stuff you hear about. What did HBR call it? That data science was like the sexiest job of the 21st century or something a long time ago. And you hear all this stuff about it.
I think that came out in 2012 or 2013 was that article. It was like a long time ago.
Wow. Yeah, we're old. That was 13 years ago. There's people born at the same time as that article, like having their bar mitzvah this year.
HBR, data science, sexiest job, 21st century. Yep, October of 2012.
Wild. Yeah, and so it kind of gives this reputation of like, oh, you're using data to change the world and you're gathering insights and you're kind of driving innovation forward. But people don't know as much about the day-to-day life of a data scientist, a data engineer, a data analyst even. So that is what we're here to talk about today.
I think data engineer was called the sexiest job of the 2020s at some point.
Interesting.
And maybe I'm making this up to make myself happy.
I feel like that's not how people in the space think of it at all. I feel like data engineering is the most toil of all the data work, and it's the most like just kind of holding things together with duct tape and like managing things and putting out fires. Maybe you could call me on that.
It definitely can be.
Yeah. Right.
I think we'll get into that too. We're going to talk a little bit about some of the not so glamorous pieces of some of these roles, right? So whether it's DevRel, data science that you'll talk about, or today I'll talk about data engineering, solutions architect, or we'll both kind of hop over the aisle of things we might know about the other person's work. We'll talk about the fun parts, and maybe we'll talk about the not so fun parts, because at the end of the day, it's a job, and so there will be parts that you don't necessarily love. And I think you have to, you should know those going into it, as opposed to just being blinded and thinking that everything is, unicorns and rainbows, when at the end of the day, unicorns still poop. So
quotable quotes. Unicorns still poop. Sam 2025. Get that on a t-shirt, guys. Yeah, and I think we'll get into all of that, but a really good place to start would kind of be discussing the typical description of the roles. And the reason I'm being so vague and like giving so many caveats is because all of these roles do tend to be painted with a really broad brush where there's a lot of overlap, there's a lot of similarity, and you end up doing a lot of types of jobs. It's just like a highly interdisciplinary space, right?
Yeah.
So I think it could be kind of cool to discuss our impression of like, what is the actual delineation between a data scientist, data analyst, data engineer on the average?
Right.
Would you want to get into your interpretation of that, and then I can give you mine? We'll see how much they even match.
So in a typically very average job description of data analyst, data engineering, and data scientist, right? We have, and then of course there's others, like we'll talk about DevRel, we'll talk about solutions architecting, but we focus on maybe the three camps of data, and of course there's a lot more too, right? There's ML engineer, there's AI engineer, there's
analytics
DevOps
engineer now,
there's analytics engineer, there's so many engineers around data, and then, but specifically with these three titles, right? Data engineer, I think there's a guy named on LinkedIn named Andres, I think is his name, or Andres. I think he's from Europe, and he calls himself the plumber of data science, right? And I do think, or the data space, and that's because he's a data engineer. And I think that has a lot of truth in it in a lot of companies where your role is taking data from the source or from a source within your company's data, right? So maybe it's not in your company's database or your data lake or data mesh or all those other terms we could use. And then we have to bring it in to the company's data hierarchy, or
Mm-hmm.
it's sitting somewhere in the company's data hierarchy in its raw form, and we need to then begin that movement through the pipeline, or both, right? A lot of times we'll do both. And
Yeah.
we think about the medallion architecture, or just whatever we'll call it. Medallion architecture is not even a real term. It's just something that was a marketing term that was coined by Databricks because it sounds cool. Uh,
Right.
but really moving through our zones of like raw, curated, and then like an integration or a published layer, and moving data through those is oftentimes the role of a data engineer, right? Obviously, there's exceptions and caveats to that. And then once you land at our publishing layer, a lot of times that's where data analysts will pick up and they'll be building models or they'll be building dashboards or informative reports, if not in form of dashboard, in some other maybe Streamlit application or something that just allows business users, product engineers, product owners, project managers, whoever it might be, to get a better idea of the business and what's going on and what questions can the data answer. And the analyst will oftentimes work very close to the business to build those reports out so that way it's an iterative process between the analyst and the business to get the right information presented to the right people that provides the right value, right? Which is why it's an iterative process because every company is different in terms of right information, right value, right process. It's hard to get that, which we can talk about later, the requirements gathering piece of like a data analyst work. And then the data scientist is somewhere kind of in the middle of that, right? They're pulling data from maybe sometimes even the raw layer, and they're building models off raw data, or they're building models at kind of like an intermediate stage where the data has been cleaned but not necessarily aggregated because they need more granular data to build their models on, maybe hourly or daily or something like this, or even more granular than this to build some sort of prediction. I feel like data scientists have to be a good data analyst first, and then they have to be also really strong technically in terms of being able to get the data, work with it at scale, and build models at scale that are like you can replicate them and build them out in forms of like experiment tracking with ML flow, something like this. So the data scientist is working closely to both the data analyst and the data engineer to build out usually machine learning models or some sort of predictive or prescriptive form of analytics that's usually using XGBoost, right? I mean, everyone uses XGBoost. Who doesn't use XGBoost? It's usually what you're touching.
Yes.
Uh,
Yes. You will
there's
do a whole literature review, build a baseline model, run through all the steps just to land on XGBoost, pretty
XGBoost.
much.
Yeah, I mean, you think like logistic regression, like no, just XGBoost. Everything just boosted. Uh, and I feel like for me, that's the three uh, elements of those roles. The delineation and the differentiation between them is sometimes more clear in some places and less clear in other places. It really does depend on the role. But for me, as a whole, those are how those three roles kind of differ, even though they're all kind of touching the same data. They're touching the data with different goals in mind or at different points of the life cycle of that data.
Yeah, I think you gave a really good idea of like the experiential differences between them. So I'll focus a little bit more on like mostly just my opinions, honestly, about like the
Mm-hmm.
skills and the stakeholders, which I feel like
Mm,
that's the real delineation for me that I've seen as I've done so many areas of the data fields. Um, so for me, everybody has SQL, data science, stats 101. Everybody in this camp, if you want to work in data, we need to have good number sense. We need to understand like how to data storytell and work with
yep.
data at a basic level in SQL. And there are some analysts where like that's where they stop, right? And that's their
Yep.
entire skill set. And when you have like these really clearly defined roles in places like Fang, you have people, they're literally their only job is to run A/B tests. Literally their only
Mm-hmm.
job is to run ad hoc SQL queries to support some team, right? And the less structured your role is, the smaller your business is, the smaller your team is for data, that's when your role really begins to be quite broad. And you might end up being like a full stack person who does all of this stuff.
Right.
So then when it comes to data science, we take that base skill set of stats, SQL, number sense, data storytelling, and we add a layer of machine learning on top of it. And that means like understanding how to predict data, understanding how to identify, is this a classification problem? Is this a regression problem? Confusingly, the main classification model is called logistic regression, but we don't need to talk about that. We can ignore that. But moving on from there, then data engineering is basically the most upstream thing you can do in data. So how does the data land for the data scientist or the data analyst to be able to utilize it? That's where the data engineer comes in. And this is why software engineering becomes more and more important in data engineering, because you have to understand how to optimize. If you work at a place like Netflix, you're moving petabytes every day probably. So you need to really understand where those optimizations are, how do Parquet files actually work, how does data move safely and securely and without lossy compression type of stuff. And that's why software engineering is kind of the layer on top for data engineering. So to recap what I said, it's this core skill set of stats, number sense, and SQL. And on top of that, you'll have like Python and ML for data scientists. And then for data engineers, you'll have like Python, sometimes R mixed in there, plus software engineering. And the difference here is that like data scientists know how to make computer do math, and data engineers actually know how to write code. That's like what I've seen a lot, which is like no hate to anybody, but it's just about what you learn it for. Like, are you purely using it as a tool, or do you actually know like design patterns and like some computer science stuff, you know? So to me, that's the skills. And then I'll quickly go over the stakeholders, which is something I've been thinking of in more recent years as I've done like data analytics projects when it wasn't really my job title, and trying to understand like how that role actually works. So for data engineers, as we said, they're the most upstream. They're getting the data where it needs to go. Their stakeholders are going to be technical users usually, right? Your data is landing for business analysts, data scientists to work with. Whereas for data scientists and data analysts, their stakeholders could be like the CEO. And you need to just like make number make sense, give a great presentation, where your job is really decision support. And all of this technical knowledge is kind of sitting beneath the iceberg, just helping you like make those decisions in a meaningful, statistically sound way. So your stakeholders are people that have never written a line of code in their life most of the time. And so you're constantly translating and having to explain highly technical processes to non-technical audiences. Whereas I would guess data engineers, even though I haven't held the title, I would guess data engineers don't have to do that all that often, because you're actually dealing with more technical people as your end stakeholder.
Right. I would, having worked in that camp, yes, absolutely. Like the people I always met with, like we had, so currently I'm in solutions architect role, but previously been in data engineering roles. And where I was working in, especially at IQVIA, right when I was working at IQVIA, all of my stakeholders here had, they were all like statisticians, right? Like biostatisticians, or they were using words like p-value, right? And t-value and like all these statistical terms that because I worked in data science, like I know of them, right? It's been a few years since I've worked with them, but I know of these things. And so like when they say p-value, I'm like, okay, yeah, p-value, like whatever. Like we have to speak
Whatever.
that, I have to speak that language. Whereas then their stakeholders, right, are people where they wouldn't think to use p-value in a conversation with someone who they're presenting results out to, or maybe they do in like a roundabout way where they say like these results were significant, but they don't say p-value, right? But to me, they could just say p-value, and I'm like, okay, I got it, right? So there's like different levels of conversations we have.
Totally. Where like the technical translation that you're doing is more of like, okay, how am I translating my data to suit the needs of ML and be able to have that conversation about like
Yeah,
deep statistics and machine learning algorithms. And then their job is like explain like I'm five, basically.
right. They're like, I need to run a one-sided p-value test. I'm like, okay, like let's talk about how I set the data up for you to run that test.
Right. Yeah, I love it. I love it. And you know what that means? Can you explain what that means, Sam?
What, a
Just
one-sided p-value
curious.
test?
Yeah.
Okay, so what is a p-value?
I actually, my first and only like deeply viral LinkedIn post was explaining the p-value. A p-value in statistics is the likelihood that we would find the results we did given that the null hypothesis is true.
Right,
So, like, it could be if I said, hey, Sam lives in Bangladesh. That's my null hypothesis. And the truth is, you live in the United States. There's very low odds that we're going to find like a high statistical likelihood of that because our null hypothesis is so out of the bounds of truth.
right,
So then the alternative hypothesis, the H1, would be Sam doesn't live in Bangladesh.
right. And then we
So
either
that's
either we either
yeah,
reject the null or we fail to reject the null. Good old
exactly.
scientific terms.
Very scientific. We don't prove things, we disprove things, and we find evidence for things. I love that about science. So
If
yeah,
you disprove 9 things and you had 10 options, that 10th option's looking a lot better than it did at first.
yes, but you didn't prove it, and that's
But
very
you still
important
haven't
because
proven it yet. You're just saying
yes,
maybe.
the next person comes along and says, "Oh, there was actually an 11th option, and now you have evidence for two." Right?
I have to disprove one more.
Exactly. So that's how science works. We love science here. We're very into that. And then the one-sided nature of the test that you mentioned means that we're looking for like a greater than or a less than basically condition.
Right,
And we're not looking at both ends of a distribution. We're just like, okay, it's on this side or that side.
right. And I had to
Yeah.
make sure that they were running these efficiently, right? So like they'd provided some code and then we were porting that code over to Snowpark. And so I didn't have to worry about the code that was doing it. I just had to worry about, okay, does this code that they gave me, does this work well in Snowpark? And like, can I do
Right.
something better to like I didn't have to go into the math library in Python or scikit-learn or NumPy or whatever they were using to build that. I just said, okay, do these things to cooperate well and does it run fast? Uh, and the answer was no, it definitely didn't run fast at first because the data scientist built it. But then after I was done with it, yes, it ran a lot better.
Love it. And this is the team synergy, right? Where like I could write the worst, most garbage, not optimized code to get my p-value test to get my answer for my decision support. Then I say, hey, this is sucks and we can't run this at scale. And I give it to Sam and he knows how to do his PySpark Snowpark magic and he can make it run well.
Not always. Sometimes I'm still not good at making those things happen. And sometimes there's reasons why we can't parallelize things. But a lot of times, yeah,
Right.
there's something we can do. We can multi-thread, which is challenging. We can async. We can make a lot of calls at once and wait and then come back and check the results. Like there's a lot of different things we can do.
Mm-hmm.
Uh,
Just throw
it,
DuckDB in it.
yeah, I mean, I just throw DuckDB at it and polars, and it'll probably work.
Yeah. Pretty cool.
Dask, Ray, just keep going. There's a lot of tools you can use.
I feel like we have so much value here where we're going to go through all the stuff that data engineers and data scientists do, but then we're like, just use XGBoost, just use DuckDB,
Yeah,
you know?
honestly, just make your life easier.
Yeah, at least try it. Um, yeah, so I feel like from here we could kind of get into whatever you could say about this project and hear what a day in the life as a
Yeah,
data engineer on that project is kind of like.
I like that. The day in the life of a data engineer. ChatGPT, tell me what. No, I'm just kidding. Um, I think again, it really depends too on, and we'll caveat this. I think we have to caveat like every piece of this conversation with
Yeah.
your experience, right? So I've done data science at 4 or 5 companies. I've done data engineering at one, and I've done solutions architecting now at one, right? So I've been at a lot of different places along the data life cycle, and I've seen how data works. I'll say my title was data science at a lot of places, but I was more so doing analytics or engineering work than necessarily model building like the traditional data scientist would.
Yeah.
Um, but in this data engineering role, right, and thinking about what I know about my friends who are doing data engineering too, outside of just me, a lot of times, well, we had on call, which was also fun. So a lot of times my day would either start at 9 o'clock like it was supposed to, or it would start at 6 a.m. It just
Yeah.
depended on the day and what was going on. But say you started, normal time at 9. uh, do what you do to log on, right? You check your emails, check your calendar, you see what you got going on that day. We had stand up, we had daily stand up at 9. So we would get on, we would hop on, we'd talk about what we're gonna do, what we did yesterday, what I'm gonna do today, and what I'm setting up for tomorrow. Right, and that was the meeting every day. We can get into the productivity notes around doing those types of meetings and if stand-ups are a good idea. I think sometimes they are, sometimes they aren't. And that would pretty much set our course for the day. But the project I was on was code, right? I was coding, I was building. It was a big migration from Hadoop Scala into Snowpark and Snowflake. So I had to
Wow.
get in, I had to, on the job, learn Scala because I did not know Scala. Uh, I had never worked with like a Hadoop instance, Cloudera, Linux edge nodes, Scala. Like I had never done any of this. Never worked with Java either, so I didn't have this idea of like compilation, right? Python was my first language. So when you
Right.
come from Java, if you were coming from Java going into Scala, it'd be like easy, right? It's like cool. But going from
Right.
Python into Scala, there's a lot of other things you have to consider when you're compiling and packaging and building these things. So I got a lot of
Yeah.
experience with that, and a lot of my time at this role before the project really got too deep was learning Scala just by trial and error, right? Like teaching myself how to compile a Scala package and like what does that mean, and all these other things like modules. So I got to learn enough about what I needed to know to understand the code base that I was working with, which is also another thing, like your 80-20 rule of like just learn enough to be dangerous and then make it happen. And then I also
Totally.
had never worked at that level in Snowflake, so it's my first time working actually at all in Snowflake. Every place I had ever been was working in Databricks. So this is my first time with Scala and my first time with Snowflake, so that was a lot of fun. And at a certain point, we talk about imposter syndrome, all right? And like, do I need to be here? And my thought was, wow, I haven't worked with any of these things before, but I'm confident in my abilities to learn on the fly and learn what I need to know. uh, I did have the help of ChatGPT when I didn't understand a concept. Like, hey, can you explain this concept to me? Like, can you break down what's happening in like a while loop in Scala or like a for loop or like how are they defined? So I could begin to understand what was going on and then move that over into Snowflake and learning a lot about how to test, right? How to reduce your feedback loop. Data engineering, I think, is really important to learn in any of the data fields. It's really important to learn how to reduce your feedback loop when you're developing locally and then trying to deploy that out somewhere. You don't know how the deployment process is going to go. And so the more you can do to reduce your feedback loop in terms of I write code, I test code on deployed instance, and I can see that that code's going to work, whatever you can do to get that time down is really helpful for anyone in this space. And that's mostly what I did, right? I was writing
Wow.
Snowpark code in Python, building out like the whole architecture for this thing. So I built data models. Uh, we worked as a team to like build these data models. We built the modules that ran through. We built the orchestration. We built the error handling and the logging, and essentially built everything from the ground up on this project, converting it from Scala, but also adding a lot of things that were lacking in the Scala version of this thing. And now we can also get into the benefit drawback of like, did we really need to move that whole code base over uh, from scratch? Probably not. And those are definitely things we can talk about in terms of, okay, why am I doing this project? And is this beneficial to the organization? Um, ours, I didn't have a lot of control over those. I asked a lot of those questions, but I didn't necessarily have a lot of control over if those questions actually made a difference. So I would encourage people to ask those questions when you're considering a project of that scale.
Yeah.
But my day, to get back to the root of that question, in data engineering was a lot of coding and a lot of meeting with teams to understand the code base that we were porting over from, to understand like, hey, what does this do, and why was it built like that? To then begin to understand, do we need to build it the same way? Can we build it differently? Right? What limitations existed when this thing was first built? Do those limitations still exist, or do they not exist anymore? So this was like brownfield migration projects, which is what you could like categorize this as, which is different from like a greenfield a value add project, right? Which would be like, okay, we don't have this thing, we want this thing, and your life is going to be a lot different. Whereas my life was very much brownfield migration, so I knew what I had to do, right? I knew I have to port these things over. I'm expecting this performance, but that almost made it harder in a way because you had to do like you're moving it over to a new language and technology, and we're trying to expect the same final results, which is where you
Hmm.
really learn how like intertwined things are that you don't think are intertwined. That's why code bases, we often say like please don't touch them, because if you like take one thing from the middle shelf, the whole thing falls apart. Like that's what happened here. So it was really interesting to learn that. So a lot of meetings, a lot of documentation, and a lot of coding. I think I provided over 100 pages of documentation once I had finished like building the V1 of this, which they're probably now on V3 or V4 at this point. But on the V1, I built over 100 pages of documentation because this was a complicated system. And so I think something else people should get good at in the data engineering and any data space, something we don't give enough time in respect to, is documentation of processes. That was a
100%.
long answer, but that was my experience in data engineering.
Wow. I have so many questions, and there's so much I could ask on it. Um,
Good thing we have
yeah,
more
I
episodes.
yeah, I think we have more episodes to just dive into like what is the difference between a well-run project and a poorly run project, both from like I guess the PM standpoint of like planning and
Mm,
investing
right.
resources versus from the engineer standpoint of like, okay, how am I being given the tools and time I need to actually learn how to do this? Is there like follow through so that people know what's going on and there's documentation, and like if I need to leave this job for some reason that someone else can actually pick it up.
Hmm.
um and there's so much to talk about with like a well-run project versus like, oh, they can figure it out, you know.
Right. And you're right. The PM is going to care about. I think this is really important for us data people to understand. Like, your PM cares about, I've given you 3 days to do this task. Is 3 days enough time to complete this task? That's what the PM's thinking, right?
Yep.
What we need to be thinking is, you give me 3 days to do this task. Okay, first of all, do I need to do this? Like, is
Right.
is this something that needs to be done? I think
Totally.
oftentimes we don't stop and think about those questions, which is really important. Uh, and you might not have the answer to that, and that's good because it means you should ask someone, why are we doing this? Because I think that's the
Yeah.
first thing. If we can't justify like the work we're doing, or we can't give reason or rationale or some sort of, I don't like the word term business value, right? But if we can't show any value or reason for doing something, and we're just doing it because either someone told us to do it or because we read on the internet it's what we should be doing, right? There's value in understanding why it is we're doing what we're doing, so we can get ourselves right. 3 days to do this, do I even need to be doing it? If so, okay, let me think about the steps required to do this task, right?
Yeah, totally. And it's probably harder with engineering, and you could correct me if I'm wrong, but when you're doing data science or data analytics work, which is the majority of my career, it's very easy to ask, okay, what decision is being supported by this?
Mm-hmm.
It's very easy to ask, okay, who's using this model?
Yep.
Is it part of a marketing campaign? Is it part of like an executive decision of where to invest time into marketing channels in the business? Or
Right.
is it just a cool idea someone had? So they said to ask the data scientist about it. I did a project recently in my last company, or not that recently, I suppose, where my job was to basically estimate the impact of AI tooling on lowering support chats, meaning like you can just ask our AI tool instead of asking a
Mm-hmm.
support agent, like a real human support agent,
Yeah.
like, oh, where is this thing in the documentation? You can just find that very easily, you know,
Right.
with a documentation indexer tool. And so I did some really rough estimations by basically just like multiplying rates by the projected amount of chats we would have in the future and being like, oh,
Mm,
well, 20% were estimated to be answered before. And if we grow 20%, then we can multiply numbers and stuff. And it was very rough and not that helpful. And I did keep asking, who's using this? Who is this for? And it turned out that this was for like a kind of malformed decision support process that didn't end up going through. But actually, we decided to evangelize it with the AI team that was developing tooling because they needed their own justifications for their own roadmap. And it was really valuable to them to say, hey, this is why what we're doing is valuable. And this is how we can get like concrete estimations of what our team
mm,
is worth monetarily for their own business value.
mm,
And sometimes if you're stuck in a project, it's about like finding, okay, maybe the initial ask wasn't that valuable, but you can storytell and shift this into something that is materially valuable. And
right.
that's another skill of like peddling your projects, evangelizing your projects. I think Tina Wong said something about defending your project as if you're like a defense lawyer in a courtroom.
Hmm.
And that's a lot of what you have to do in this space.
Is that for all of us, like data engineer, data analyst, data scientist, everyone?
Maybe that's more of a question for you because I haven't done that from the data engineering side. But a lot of time, it is like, hey, what's the business value behind this, however vague that
Hmm.
word is? Or it's the client saying, this isn't what I asked for. Tell me how it brings me value. Tell me why it's not a waste of my time. Because people give you stuff and then they
Yeah.
turn it back on you and say, hey, why did you do this? And that happens all the time.
I think in data engineering, it can be a little less ambiguous, but sometimes
Mm-hmm.
it's not. Sometimes it's the same level of ambiguity. Like, do I need to be doing this? And like, how do we reframe this to actually be something that's productive? So it does exist. Maybe less, right? I think it also depends on the data engineering project. I think a greenfield project is more likely to have that because you make certain decisions around technology. Like,
Uh-huh.
let's bring in DuckDB and polars, and then okay, sure. But then our team has never used those before, so now our team has to like figure out how to use them. Uh, and is it really worth the time of like making, because anytime you're learning a tool, right, you make mistakes in that tool because you're learning
Right.
it. So even our best developers, if they now need to start using DuckDB and polars and they've never used them before, well, they're going to make mistakes. And it doesn't make sense for us to give them a new technology, have them fall on their face a few times, and we're paying them to fall on their face to then like eventually get there at the end of the day, and then it's gonna take longer, right? As opposed to, okay, they already know how to write Scala, for example, so let them just build it in Scala, right? So there's also, I think, in data engineering, what we run into more so is that like technology trade-off around, these new technologies are sexy and interesting, and like resume-driven development, I think is the term here. Uh,
Yes.
uh, but then does it really benefit us to be doing something like that? Whereas we could just go with the tried and true, right, Java or Python, which are a little more like in Python, I mean, just like pandas and scikit-learn and Spark, like, the more general tools that aren't as bleeding edge, but people know how to work with already.
Totally. I also just have to call out real quick that you're using this analogy of the brown and green field well. And this is something that I only heard recently, but my team heard about some startup that is like their whole slogan is like browning the green field. And it's just like so gross. It sounds like it's like dirt and mulch and like, but sometimes these metaphors go too far.
I see what they're doing, but I don't like it.
Yeah, I don't like it. It leaves like a bad taste in your mouth. Anyway, yeah, I like the idea of what you said with resume driven development because that's actually the same thing that I would be doing as the data analyst, pedaling around my project, defending my project, because you're either trying to drive impact or learn new skills. And all of that is about your resume. Like I
Yeah.
literally was talking to someone in my LinkedIn community earlier this week because they were shockingly very inspired by my resume post that I did about like resume tips. And just thinking about your whole career as like, how can I put this on my resume and story tell this on my resume? And like, if it's between two projects for you, if you're important enough that you get to like choose between two or three things, literally think about what is the highest impact thing you can say on your resume or what is a new skill you can learn here for your
Mm,
resume. Like that's a great way to define and build your career actively rather than just taking a passive role and be like, okay, this landed on my desk, I'll do this, you know?
This is really interesting because I'm referring to resume driven development as like a negative, and you're doing it as a positive.
I know. That's why I was like, this is an interesting conversation because you
Yeah,
said it in such a like downgrading kind of way. And I'm like,
yeah,
I
yeah,
actually think it's really important because like at the end of the day, of course I care about work in the context of my company. But at the end of the day, I'm building my own career. And you might
right.
not stay at this company forever. And you need to think about what are you actually going to carry with you. This is a huge problem for like support engineers,
Yep,
for example, where their job is to learn their product, but they
yep,
can't reuse that if they want to leave.
right. They have to be able to show off like I learned this and caused and created these like outcomes or impacts at my org in like numbers, right? We have to use like firm numbers
Mm-hmm.
oftentimes in those resume bullets.
Totally.
I
And
think
you
for
can estimate.
I was about to say I think for us on the engineering side, it's like resume driven development is like I'm trying to go after the new shiny thing,
Mm,
and it's not always productive because it's gonna, like I said, it's gonna take you longer, it's gonna cost more, you're gonna fall on your face. Whereas just using the thing you've done before means you get your project done faster. And
yeah.
unfortunately, right, we say, okay, let me build the V1 with Python and polars and not polars, Python and pandas and maybe some PySpark if I have a way to do that. And then later I'll come back and I'll try to plug in like DuckDB or polars and I'll try to see if like these things run faster, Dask or something, right? You don't have that time. Like that time's not coming back to you.
Yeah.
Like you're not gonna be able to go back and do that unless you're working like 8 to 10 every night and you just log on and like on the side you're kind of doing that on exploration, right? But you also have a life to live. And so the resume in the engineering space, like the resume driven development is that's why it happens. Because we want to build the new shiny things, we want to put them on our resumes, but we don't have time if we were to build it with the thing we already know, and then try to come back to it later. We're not coming back to it later. So it's like a thing that happens, and it's often seen in a negative light in the engineering space because of the repercussions it can have on a project, in terms of like money and time spent, right?
That makes a lot of sense. And it kind of reminds me of the software engineering principle of build one to throw away, because you can kind of afford to do that as a student or if you're like learning something for fun. But usually the first thing that works, like they duct tape it together and ship it because they just
Yeah.
need something as soon as possible, right? That's kind of what you're saying.
Yep. There's nothing more permanent than a temporary solution, is what we said. I think we've said this like 3 times over the last 2 months, at least. But nothing more permanent than a temporary solution.
Yeah, that's honestly so true. And then whatever you did is so thrown together and not very extensible and not very optimized that it's actually quite difficult to refactor it, migrate it, optimize it in the end at the end of the day.
It's like when you bring down a whole code base because you added some comments or you added like a unit test somewhere.
Oh my god, my greatest fear. I've actually never done anything like that, so I'm hoping to stay like that.
Yeah, I don't have the same experience as some other people who say they deleted entire like prod databases. I don't have that. I've never done that. Maybe I'm too scared to act like that. Uh, who knows?
Yeah, I think there is something to like keeping a certain level of base anxiety to make sure you don't make a certain kind of mistake. Hey everybody, Future Shifra here. This has been our episode on the day in the life of a data engineer. We actually split this one up into 2 special episodes, and we would love for you to check out part 2, Day in the Life of a Data Scientist. As always, thanks for tuning in, and see you next time.